This is the first example for the chapter 6 section frame and machine. Okay, so it's a frame because it's a structure that is fixed, where the parts are not moving together. So we have two parts. So first steps, let's split this structure in two. So we have the upper L shape with the point C and the point B. And we have the lower member, BA. If we look at the member AB, this is two pin connections and there is no way that's applied, so it's a two forces member. Okay, so it means that the forces are aligned with the pins A and B. So somewhere there and there. Now for the direction, is it compressed or in tension? So we push on with the 400 Newton and we rotate also in this direction, so probably compress. And if we don't guess the right direction with compression and tensions, we will have the answer when we will solve for a force with the L shape, with the equation of equilibrium. But I recommend to try to understand what's happened, and if it's compressed or tension, because it will be easier. Because after that, you have to change all the directions of the force in every the diagram. So that's FAB. FAB. That just means that there's a force inside the member AB. The directions are given by the distance. So this is 1 meter, and this is a total of 3 meters. So this distance is 1 square plus 3 square, so it's the square root of 10. So either you use the square root of 10, and 3, either you use an angle. So let's find an angle, let's say theta. This angle theta, it's equal to the inverse tan of the inverse tan of 1 divided by 3. So opposite side divided by adjacent side. So your angle is 1 divided by 3, 1/3 is 18.4. If we count, it's 18.4 degrees, this theta there. This FAB is the same force there, FAB, with the same angle theta there. The only difference is the directions. So this one was going down and this one is going up. Okay. So if the L shape is pushing on the two force member, the two force member is pushing on the L shape. Which other forces do we have on the L shape? We have some forces that we know that the forces are coupled. We have a couple that is equal to 800 Newton times meters. I drew it there, but remember that the moment, a couple, is a free vector, so you can draw it anywhere you want. We have this 400 Newton, and we have a pin connection at C, so it means that we have two unknowns, CY and CX. I draw CX to the left because FAB is going to the left. Oh, no, I have to draw it to the right, sorry. CX, I draw CX to the right because the complement on X has to balance the complement of FAB that is to the left. So it's necessary to the right. For CY, we don't know because we don't know the magnitude of FAB Y yet. So let's draw it up in the positive direction, like the axis Y. Okay, so if we look at this Fibonacci diagram at the top, which equation we will do to solve for one unknown? We need to use the moment about C, because we have two unknowns at C, so we will be able to solve for FAB if we do the moment about C. Okay? So because of that, we need to draw all our distance since the point C. So C, between C and the 400 Newton, we have 2 meters. Remember that we want the perpendicular distance with the FAB. So the FAB, we will need we'll have two complements, this FABY and this FABX. Okay, so for the FABX, for this one we need this distance, that is 1 meter, and for the FABY we will need this distance. So if the force is vertical, the distance is horizontal. If the force is horizontal, the distance is vertical. The distance must be perpendicular to the force, the complement of the force. And this total distance is 1 plus 2, so it's 3 meters. Oops. Okay, so let's write the equation now. Okay, so sum of the moment about C is equal to 0. Okay, so we have this 400 Newton that is going in the positive directions times the distance of 2, so force times distance. We have the couple of 800 Newton. It's already a force times the distance, okay, so just 800. And we have, so this, this y complement, this vertical complement that is rotating in the negative directions, time this distance. Okay, so minus FAB y, so FABY is sine theta time the 3 meters. Okay, so vertical complement is FAB time that the opposite side of the theta, so sine theta, and time the horizontal distance that is 3. And now this distance, this horizontal complement of the force need to be multiplied by the vertical distance of 1. Okay, so we have, and it's going also in the negative directions. That's a lot of things to think about it. So minus FAB, and this is the same than this one, so cosine theta. And just be careful, you cannot change the force, this vertical force, this horizontal force for there, because you don't know, the distance will be different. Okay, you need to write all the arrows together or all the tails together, but you cannot put one with the arrows and one with the tails. Okay, so if you have a force like this, you can split it in two complements like this, or you can split it in two complements like this. Okay, but you cannot make a mix between this one and this one. It's not the same. Okay, okay, so minus FAB cosine theta, this one time 1 meter, and it's equal to 0. Okay, so let me repeat. This one, 400 times 2, is this 400 times 2. Okay, and that's rotating in the positive direction. This 800 is this one, and again rotating in the positive direction. This FAB sine theta is this vertical complement, and this 3 is the distance. And this FAB cosine theta is the horizontal complement there, times this distance 1. Okay, so now we need to solve. So we have 800 plus 800, that is equal to FAB, okay, sine the theta. How much was the theta? 18.4. 18.4 times 3 plus cosine times 18.4 times 1. Okay, can you see that? So I did more than one step for one line, sorry. You can write as many lines as you want. So 400 plus 800, after that I move this to the other side of the equal sign, and I factorize by FAB. So FAB sine theta times 3 and cosine theta times 1. Okay. So we have 1600 is equal to FAB time. Okay, so you can find this in that calculator. 3 times sine 18.4, or you can keep your exact number that you found, so 3 times sine of this plus cosine of this times 1. So it's 1.897, and keep your exact number, so you find FAB is equal to 1600 divided by this. This is 843.3843 Newton. That's FAB, so that's this FAB, this FAB, this FAB, they are all the same. Let's solve for CX and CY now. Let's do the sum of the force on, which one first? On X. Sum of the force on X is equal to 0. Okay, so let's look at this problem. Let's remove a little bit the distance. We don't need the distance anymore. Okay, so we clean this a little bit. Let's clean this a little bit. Okay. So so force on X, we have this minus FAB cosine theta plus Cx is equal to 0. So we have Cx that is equal to 843 cosine 18.4 degrees. So Cx is equal to cosine 800 Newton. And sum of the force on the y equals 0. So on the y, we have the FAB sine theta minus 400 and plus CY is equal to 0. Okay, so this one, and this one. So FAB, we found FAB there. So 843 sine 18.4 minus the 400 is equal to minus CY. So the 843 sine 18.4 minus 400. It's minus 133, so Cy is equal to plus 133 Newton, because we have a minus there. Oh, so Cy. Okay, so here we go. We got the we solved all our unknown. That's another problem to the right. So we solve for FAB, we solve for Cx, and we solve for Cy. If you want to find the C, the magnitude of C, you do the square root of Cx squared, Cy squared, that is equal to, so 800 square plus 133 square, and then square root is equal to 811 Newton, the magnitude inside the pin P. C. That's definitely there. That's it for this example. So take your time, do your Fibonacci diagrams, find your two forces member, find which equation you can do to solve for one unknown. Most of the time is a moment about a pin, and after that solve one unknown per equation if you can. See you in the next video. Bye bye.